Hello everyone. Let us now discuss about naive-Bayes algorithm in Python. So here I have taken a data set which is basically PIMA Indians diabetes data set. So we need to make a model to predict whether the person is diabetic or not. So here, what is the prerequisite to understand naive-Bayes algorithm is that naive-Bayes theorem, right? So we have already seen naive-Bayes theorem in the class. If anybody have missed it already, please look into that video. I will be just giving the link in the description box. Click on the link. First, you understand naive-Bayes theorem, then you can proceed with this practical approach. So what is the problem statement I said? To predict whether the person is diabetic or not. So diabetic or not diabetic is the dependent variable here. The dependent variable is categorical. So it is a classification model, right? And with Naive we can solve only classification problems. So step number one, I have imported all the packages like NumPy, Pandas, Matplotlib, and Seaborn. Then I'm loading my data set. The data set name is PIMA Indian Diabetes Data Set. So let me look into the shape of the data. 768 rows and 9 columns are there. 768 rows and 9 columns are there. So let me display this. So this is how my data set is looking like. So first one, PREG stands for number of pregnancies, PLAS, plasma, PRES, pressure, SKIN, thickness of the skin, test, insulin test, and then mass, body mass index, pedigree function, age, and class as the dependent variable. Whenever we have one, it is diabetic, zero is non-diabetic, right? So in case if you want to understand about the correlation between the dependent variable and independent variables, you can go ahead with this code. So here, if you see, I saved it like a PMA Indian data set, right? So I have saved it like P data. You can give any name, whatever you wish, right? So when I find the correlation, class is the dependent variable, right? So this is the correlation I'm getting, but now I'm not going to focus into that. Let us just explore the algorithm part now, right? So whenever you do any classification problem, it is mandatory to check whether the data is balanced or not. So to check whether it is balanced or not, either I can write the code like dot value underscore counts, or I can also go ahead with the count plot, which will tell you about the different classes, right? Which will tell us about the different classes. What is the distribution of the different classes? Okay. So whenever you run this pair plot, it will take some time. So you have to be little patient because there are a lot of numerical attributes. It has to find out the correlation among the different attributes. So when I write a dot value underscore counts, if I run it, I would be getting how many people have diabetes in my data set and how many people do not have diabetes. So no diabetes is 500 and how many have diabetes? 268. So let me figure it out how many rows and how many columns are here. Okay, so again I have written DF, so P data. Totally 768 rows and 9 columns. Out of 9 columns, one is dependent and remaining all are independent, right? So now if you see pair plot, I have passed the data frame. In the diagonal, I want KDE graph and always make it as a habit. You can write like a hue. After hue, you can pass the dependent variable here. So whatever is blue and orange, you can see, right? So how we can understand this, you can see blue stands for no diabetic and one stands for diabetic, right? So look at this. What do you think? Blue color is more or red, orange color is more? Sorry, not red, orange. So whether blue color is more or orange color is more, you can see that more blue it is looking like, right? So that's the reason you can see that blue stands for not diabetic. You can see more data points for this one, right? So if you calculate with the total amount, I could see that 34.9 percentage people have diabetes, 65.10 percentage people do not have diabetes. Then I have splitted my data into 70 percentage and 30 percentage. Before that, we need to write X and Y, right? So I just missed to write a trade test split. So that's the part I have done here. In the x-axis, other than dependent variable, what is the dependent variable? Class is the dependent variable. So other than class, I have taken all the other attributes in x-axis. And in y-axis, I have taken the dependent variable. And then I'm splitting my data, trade test split. I'm passing x and y, test size 30 percentage, which means trade size is 70 percentage, random underscore state equal to 1 just to freeze it, right? So let me run the code now. You can see that these are just I have taken the training data. I want to see that. You can see like these many are there. In case if you write like x underscore train dot shape, you can see that 537. So if you want to find out the count of test data, 231, right? So if you add both, you will be getting the total shape, right? Total rows. Clear with that? Okay. So now we need to see whether there are missing values in our data set or not. So I'm writing df dot is null dot sum. Okay, so what is the data frame name here? So I'm writing p data. You can see that it is showing like a zeros only. There are no missing values. But if you look at the CSV, you can find that there are a lot of zeros in your data set, which is basically missing values. In your data set, for some of the data points, you can see zero, which means that they are missing values. So I want to replace the missing values either with the mean or median, right? I'm showing with the mean. You can try with the median. So when I'm just taking you through the codes, you need to pass it, you need to write down the codes. That's very important, right? Now from sklearn.impute, I have imported simple imputer. So we have never used the simple imputer, right? So we have just seen about calculating the mean value and just we try to replace it. So I'm just going ahead with some other method, okay? So this is available with the sklearn. From sklearn.impute, import simple imputer. And using that simple imputer, wherever I have zero, I'm trying to replace it with a mean, right? If you are doing with a median, you can write a median, okay? So once I do that, I need to transform my data, right? So whether you do this or not, this is not here. What I want to take is I have just taken the x underscore train dot columns equal to calls, right? And then I'm using data frame. I just want to transform the data. What I want to transform rep underscore zero. Rep underscore zero for train and test. So wherever I had this X data, all the other attributes other than class, in all the cases, wherever it finds the missing value zero, zero would be replaced with the average values, right? And once I do that, I have to implement the model now. So for that, I need to import the model, right? So from sklearn.knife underscore base import Gaussian NV, right? So I'm going to use knife base algorithm. So I'm just instantiating my algorithm Gaussian NV, and then I want to fit it with my train data, right? Once I fit that, I want to get the score for both the training and testing. You can see that 0.73 and 0.77, right? So if I want to go ahead with the confusion metrics, first I need to predict it. So here you can also write like a model 1, model 2, model 3. So what I want you all to do, take the Titanic data set. Already I told you to use, take both, right? Titanic and also that breast cancer data set. You have already worked on logistic regression and also KNN without standardization. Then try with the KNN with the standardization. So already we have done 3 models. Fourth model, you can also try with this Gaussian NB, right? So I also want to check the score. You can see 7.3 and 7.7. To go ahead with the confusion matrix, I also want to do the predicted values of Y. I have given some other name here, diabetes underscore test underscore predict, right? So this is completely up to you. However you want to proceed it, you can proceed it, right? So now let me check with the confusion matrix, okay? So from sklearn import a matrix, this step is optional. And then I want to make the confusion matrix, the same thing only, like however we do it usually, the same thing I have taken it here. But what we need to change, this is actual Y. The predicted value, whatever name you have given, that only you need to change it, right? And then labels is equal to 1, comma 0, I have written. And once I get the output, you can see that true positive is 55, true negative is 123, and you can see here false negative is 30, false positive is 23, right? And if you want to print the classification report also, we can write like print classification report. This is actual Y, predicted Y, and labels equal to 1, comma 0. So what do we get here? One is like accuracy. If you remember, true positive plus true negative whole divided by true positive plus true negative plus false positive plus false negative. And then the next one is like a recall. Recall is basically true positive plus true negative divided by the actual positive values. So this is what we are getting for class 1 and class 0. Precision is basically out of predicted positives, how many are true. Precision means out of predicted positives, how many are true. Recall means out of actual positives, how many are true. F1 score is 2 into precision into recall divided by precision plus recall, right? So what is the score I have got around? I have just got around 73 and 77, right? So what you need to do with this data set, I'll just share the link of the data set also here. You just do logistic regression and scaling standardization with the logistic regression. Try with that, let me know. Also try KNN model, then KNN with the standardization, and then also try this naive-based model, right? Try this naive-based model and let me know the scores. Totally 5 models I'm expecting, right? So I hope you would be able to do it. Thank you.